All right, in the last video we talked about the 5 basic shapes. Now we're going to see how those shapes change when we start putting lone pairs on the molecules, okay, or on the central atom rather. But basically what we're talking about in this video is molecular shapes. And instead of shapes, sometimes it's called molecular geometry. And it really doesn't matter. So the basic shape doesn't change as long as there's no lone pairs on the central atom. So that's where we're going to start. We're going to talk about two atoms, and when I say two atoms, I mean two terminal atoms on the central atom. Okay, and that's just two things, right? So the shape doesn't change. We have this. And that gives us a bond angle of 180 degrees, and that is still linear. And if I was going to give you an example of that, it would be CO2, because if I do the Lewis structure for CO2, it looks like that. Notice there's two oxygens on the central atom, okay, in the central atom's carbon. It doesn't matter that they're double bonded, single bonded, and it doesn't matter how many lone pairs are on the oxygens. I'm only concerned with the two things on the central atom, okay, and that gives us a linear shape. So carbon dioxide is a linear molecule. Next, if we have three atoms on the central atom, and I'm going to stop writing on the central atom, so we're going to have three atoms here. Okay. What is that shape? Well, it's the same as it was a little while ago in the last video. And if you remember that bond angle in the name, that bond angle was 120 degrees. And the name was trigonal planar. Trigonal planar because everything lies in one plane. And again, if we do a Lewis structure for what that might look like, that would be BF3. That would be a good example of that. But that's not the only example. NO3 would have the same shape. But BF3 has three atoms on the central atom. And we don't worry about what's on the fluorine. Okay, and that's trigonal planar. Next up, we're going to have two atoms, and one lone pair. Of course, that's a lone electron pair, all in the central atom. And that is still three things. Now, here's where the shape is going to change. Okay, so if it was just three things and we didn't care what those things were, we know it would be trigonal planar. But what happens when we have three things and one of those things is a lone pair? And we tend to put lone pairs in that little kind of lobe, we call it. We'll talk more about what exactly that means, but that's a lone electron pair. I guess it was already written there, wasn't it? Could have just pointed an arrow. Anyway, so when we look at this molecule, we don't actually see those lone pairs. We see this, the part that I just highlighted in green. That's all we see. But those electrons have an effect. And what is their effect? Well, they repel those atoms, just like atoms repel atoms. And so they push those atoms down. Okay? So what we find is this shape is called, it's a highly technical name, this is bent. Okay, it's just bent. And a good example of a bent molecule would be SO2. And you don't have to draw it necessarily correct in your Lewis structure in order to get the right shape. Because, you know, for instance, you could draw it like this. you could draw it in a linear fashion. Does that tell you what the shape is just because you drew it on a piece of paper? No, absolutely not. You still have to recognize that we have the one lone pair on the central atom, and then we have the two terminal atoms. Okay? And that's what gives us that bent shape. So it doesn't matter how you draw it on paper, the shape is always going to be bent, okay? Because we have the lone pair and the two terminal atoms. And what is that lone pair doing? It is pushing those two atoms down into that bent shape. So we don't see it when we look at the shape of the molecule, but it is very, very important. Okay? Now we're going to move on to four things. But we're going to start with four atoms on the central atom. Okay? So this, as long as it's just atoms on the central atom, the shape is the same as that basic shape. Wow, that was not what I meant to do. Here we go. And it doesn't matter which position you put the wedge in, I just try to keep it the same every single time. Okay, so just to recap, because I know it's been a little while, but these guys, actually I don't know if it's been a little while, you might just be watching this after the other one. Anyway, those two that I just highlighted, or that bond, excuse me, those two bonds, they are in the same plane as the screen. Okay, this blue, that's sticking out at you, and then the green is going back behind. I'm going to stop doing that every single time, but I just want to make sure you guys remember. And what do we have for our bond angle here? We have 100, nope, 109.5 degrees. There we go, 109.5 degrees. And hopefully you remember the name of this. This is tetrahedral. Tetrahedral. And a very, very common example of a tetrahedral molecule is methane, CH4. So there's a methane molecule, and that is tetrahedral. 4 atoms on the central atom, that is why we get that shape. Okay, now let's see what happens when we take that basic tetrahedral shape and we add a lone pair. And after this video, I'm going to go through on the modeling program and show you all of this. All right, so now we're going to have 3 atoms and 1 lone pair. And I'm going to start abbreviating lone pair as LP. Okay. And that's still 4 things, remember? Still 4 things, still that same basic tetrahedral shape, but we're just going to modify it a little bit. There's our central atom. We'll put the lone pair up there. And we'll put an atom here, and right here. Okay? So, that same basic tetrahedral shape, because of the lone pair, and actually, if we want, we can put that in that lobe up there, sorry. Okay? That's just indicating that those electrons do take space. Now, if I give you an example of what that might look like, that would be NH3. So NH3 ammonia has that shape. Okay? I guess I should tell you what that shape is, shouldn't I? This is trigonal pyramidal. Trigonal pyramidal. What you find when you look at this is the hydrogens, they would sit on, say, a surface, like if you put this on your desk as a model, and the nitrogen would be sticking up in the air and form a little pyramid. Okay, one more for this video. We're going to do 2 atoms plus 2 lone pairs, and that's still 4 things. Charge clouds, electron clouds, whatever you want to call them. Okay, so here we have a lone electron, or a lone pair, another lone pair, atom, and atom. Doesn't really matter how you want to draw them. Again, those are atoms, they're not all oxygens. And very common molecule with this shape is water. Okay, and what shape is that? Well, if you look at it, it looks familiar. That is bent. And so there are two different ways to have a bent molecule. Okay, so just remember, we're looking at the central atom, we're looking at those lone pairs there, and then the two terminal atoms. That's what gives us that bent shape.